So when we talk about the planets, and remember that there are 5 planets that you can see with the naked eye. And has anybody been out recently to see a few of the planets out in beautiful, right? Mars last night, Mars and Saturn and Jupiter were just really nice to look at last night. Wilkes, did you have something to say?
I was kind of like the night before last, like the sky was really, really clear.
Yeah. Yes, it was very nice. The moon is also in a really cool phase right now. It's in a waxing crescent, which is nice. So it's getting bigger every night, but it's in the sky. So tonight it'll be like in the middle of the sky when the sun sets. So in the middle of its path across our sky here. Very, very cool. But we can see 5 planets with our unaided eyes, right? We can see Mercury, Venus, Mars, Jupiter, and Saturn. In 1781, Uranus was discovered. It had been seen before by people, but it had never been tracked and like understood that it was another planet because it is so dim. You can only see it on very clear moonless nights. It's very, very, very faint. And only people with exceptionally good eyesight can see it. But William Herschel, an astronomer, discovered that it was a planet. So he was English, and he was a scientist who depended on the government to give him money to do research, right? So his main source of income and the people that were supporting his research were the British government, really the king, right? And at the time, the king of England was George. So for a while, the official name of Uranus was George. Okay? George the planet. Thankfully, they made a decision to not go with George. I would argue they could have made a better decision instead of Uranus, or at least really promote the correct pronunciation of Uranus. Uranus, because it just sounds better. Sounds a lot better, but so be it. So we didn't always know that our solar system had more planets out there. Okay, the discovery of Neptune was in 1846. It was discovered by 3 scientists working together: Urbain de Leverrier, Johann Gottfried Halle, I think is how you pronounce the last name, and John Couch Adams. His middle name is Couch. Leverrier was a mathematician. He was not an astronomer. He simply took some numbers and predicted the existence of Neptune. Okay? And we'll talk about how that works in just a second. Oliver?
What numbers?
What numbers? I'll talk about it. All right? So 1846, discovered by 3 different scientists. So what happened was Uranus had been discovered. Let's see here. Uranus was discovered in 1781. Okay? So there was about 60 years between the discovery of Uranus and Neptune. And people were looking at Uranus and its orbit, and they were trying to understand how it was orbiting the sun, and something was strange about it, okay? So there were discrepancies in Uranus's orbit and the laws of Kepler and Newton. So they took Kepler's laws of planetary motion, and they took Newton's laws of universal gravitation, and they were calculating what the orbit of Uranus should look like. And things were strange. Things were just slightly off. That it deviated in its orbit in a way that they did not expect. And so Leverrier, that's really hard to say, Leverrier, he did the calculations based on the orbit that Uranus should have and the orbit that we observe from Uranus. And he calculated that there should be another planet in an orbit at a specific coordinate in the sky. Okay? And he said, it should be right here. And he sent that calculation to Hawley and what was the other guy's? Adams, okay? And they both found it the same night that they got the letter from Leverrier. And it was within 1 degree of his calculation. That right there is the power of scientific prediction. That we can look at data and say something is weird. The only way that we could explain that is if there's this thing that we haven't discovered yet. Now let's see if we can find it. Okay? This is really cool. And this is, in my opinion, one of the most important things for us to understand about science in general. So for instance, black holes were not known to exist, right? We haven't always known about black holes, right? And there was a guy that you probably have heard about. His name is Albert Einstein. And he was thinking about gravity. He was doing calculations about gravity. And he said, based on everything that we know about the universe and physics, there should be these things that are unbelievably dense and massive that pull light in. And the idea of a black hole was born, but we didn't know that they existed. And in fact, we didn't really know that they existed until we took a picture of one. We knew that there was weird stuff happening in the centers of galaxies, and we assumed those were black holes. Based on all the calculations, we said, this fits Einstein's idea of what a black hole would be. And this fits all the math, everything looks right, but we don't know for sure that things are actually the way that we predict them to be. And what's really cool about the black hole example is that the image of the black hole, which of course is an extremely famous image. Yeah, right above the projector, but I want to show the people at home. Very famous image, right? What's really cool about this image is that scientists around the world had to work together to make this image. But before we even got the full rendered image, before we even got the data from this project, people were predicting that it would look something like this, right? Just based on the calculations and what we understand. This here is, okay, that doesn't work. Before we had a picture of a black hole, this is what it looks like, what it would look like up close. But this image was made before we had the image of the black hole. Okay? So pretty amazing that we are able to take information that is just raw data, raw numbers, and translate that into making a prediction of of an undiscovered something. Okay, pretty cool. And in fact, I was super proud of this last week. This is just kind of a little side tangent. For Rocketry Club, we have this thing where we take the humidity in the air and we calculate how much that's going to affect the performance of our rocket. And we calculate how heavy the rocket should be in order to hit our target altitude, which is 800 feet. So we calculate all that, and then we change the weight of the rocket to make it work just the way that we want it to. And we launched the rocket last week, and we got 804 feet. I think it was 804 feet, which our target was 800. So we were able to make a prediction using data, using science, that if we make the rocket this heavy, it should go this high. And our prediction was 800 feet, and it was 804. So pretty amazing, okay? Pretty cool stuff. We're gonna skip over this. We need to talk about, well, let's talk about Clyde Tombaugh really quick. He discovered Pluto in 1930. Remember, Pluto is a dwarf planet. It is not a full planet, but we'll talk about those later. But Tombaugh, this guy, ignore this last sentence. This assumes that you have looked through my telescope, which we have not, because I don't want you all touching my telescope for obvious reasons right now. So anyway, his telescope is actually not that much bigger than mine, not that much more powerful, but he discovered Pluto in 1930. What I want to talk about, though, is a guy named Mike Brown, and his literal Twitter handle is Pluto Killer. He discovered a whole bunch of dwarf planets that cross the orbit of Pluto. And he is the reason, essentially, that Pluto is no longer a full planet and why the categorization of dwarf planet exists. He's predicted Planet X. Has anyone heard of Planet X? Yes, a few of you? Okay. This is an animation of Eris. Not animation, rather a artist's concept of Eris, which is a dwarf planet. Mike Brown proposed Planet X. So here's what's weird about Planet X, okay? So remember how Neptune was discovered using just math? Planet X is kind of the same thing. And here's the issue, all right? Whole bunch of people take this idea and just go crazy with conspiracy bullcrap. Okay? They're like, Planet X is going to come and crash into the Earth, and that's going to be the end of the world, and like literal ideas like that. People are insane, all right? But what we need to understand is that there is a possibility that there are other planets in our solar system outside of what we understand about the 8 planets, okay? So Planet X is a hypothetical planet. I was hoping that they would have a chart of, I'm looking for a specific image. Planet X orbits. Here it is. That's what I wanted. Okay, or some people call it Planet 9. People have so this name, Nibiru, I think is what it is. Don't look up this name. This name is associated with all sorts of conspiracy bullcrap. Okay, Oliver immediately goes to look it up. What did I just say, Oliver? All right. So there are these. You can see the orbits of these planets. So Saturn is the yellow, Uranus is the light blue, and Neptune is that dark blue. So for scale, these are huge. These are objects that have been discovered in orbits around the sun. They're very elliptical. Something has disturbed these orbits. Something very large has disturbed. Oliver, did you find some stuff? I can see that you found some stuff, Oliver. It's fun. It's fun conspiracy bullcrap. That's what it is. These orbits have been disturbed by something. And the best explanation is that something has disturbed their orbits and that something orbits a long way out in the solar system. Something like it would take a few thousand years for this proposed planet to go around the sun one time. Okay, this is a huge orbit. And you could say, well, why haven't we discovered it yet if we have like telescopes and everything, and we know kind of the general direction that we're looking, but the problem is that it's really far away. And that isn't so much an issue for because it's like small. It's an issue because it doesn't reflect the sun's light very much. And that's the only way that we can really see things in the outer solar system is by looking at where the sun reflects off of stuff. So this is a hypothetical, a proposed planet that is about the same mass as Neptune that orbits in this huge orbit way out in the solar system. We have not found it yet. Have not found it yet. If we do find it, that would be pretty big news. But this is one of the only really viable explanations to explain why these asteroids and dwarf planets orbit at such strange intervals and directions. Something has disturbed their orbit. So some people have proposed the name Nemesis for this planet, which would be pretty sweet.
Isn't Nemesis a star?
Not that I know of. There used to be an idea that there was a planet that orbited the sun in the same orbit as the Earth, but was exactly opposite the Earth in its orbit, so we could never see it. It was always behind the sun. People called that Vulcan. So it doesn't exist. But
It'd be cool if it did, though.
it was an idea, okay? So there are still things to be learned about our solar system. Okay? And I think that's pretty sweet. Still things to be learned about the solar system. Boop. Yeah. So I'm going to stop this recording, and then we'll do another one for the next topic.